A very good day to the viewers of this video, which are the examiners, my supervisor, Mr. Yap, and Madam Alida. My name is Timothy Low with the student ID B02170025, and here is my FYP2 video presentation. My FYP2 project is entitled as Brother I, as shown in the text below, and the contents of this video will be a short introduction as to what this project is all about, and then in the middle I have the live demonstration of the product, and then we'll end it up with a summarization using an academic poster. So without further ado, let us move to the introductory slides. Introductory slide of Brother I. So what is the Brother I project and what are its objectives? So the Brother I project aims to develop a smart stick that detects a pothole and notifies the visually impaired user the dangers before them. And why I mention specifically potholes, because this project uses machine learning to help differentiate between a flat road maybe or a pothole. Or by right in the initial stages, I wanted to do maybe object detection or overhead obstacles, but I was recommended by my supervisor to target only potholes for the machine learning section because the duration of my FYP project is not really sufficient to cover all factors in the outside world. So that's why we only target potholes for this project. Secondly, Brother I aims to develop a mobile application that heat maps the location of a detected pothole so that it will notify the visually impaired user about nearby potholes in the area. So this will help the visually impaired to actually remind themselves of where the pothole was detected so that they can have more precaution when they go into that area. Lastly, Brother I is created to enable the sharing of current geolocation of visually impaired users through messaging applications. So this is just so that in case the visually impaired user were to fall down or something were to happen to them and they do not know where they are, they can use this function to notify their emergency contacts and let them know where they are currently. The Brother I project was designed for three main purposes. The first one is to help the visually impaired walk on the sidewalk without any fear of falling into potholes. Secondly, Brother I was designed to warn the visually impaired in advance of the potholes they may face. So this one solely ties to the second objective just now, whereby I use a heat mapping function or a saving function to save those detected potholes so that the blind user can actually know in advance of where the potholes are. So the last purpose of Brother I's design is to locate the visually impaired and notify their emergency contacts when disaster strikes, as mentioned earlier in the objective session. Brother I is composed of three main components. First one being the Arduino Nano, which will be the brains of Brother I itself. Ultrasonic sensor, HCSRO4, which will be the eyes for the blind user. And finally, it will be the Bluetooth module, which will be the bridge between the Brother I blind stick and the Brother I mobile application. So the development technologies that I use to create Brother I are as such: React Native as the mobile application framework, Firebase as the database to store all the detected pothole locations, Python scikit-learn as my platform to train my machine learning model, and finally the Arduino IDE, Integrated Development Environment, to code out the logic so that I can pass it over to my Arduino Nano for it to run. We now move to the next fun bit of this video presentation, which is the live demonstration of the application. However, I won't be doing it because I can't have potholes indoors. However, I will pass this time to a lovely young gentleman who so willingly volunteered himself to do the live demonstration of the Brother I system. So without further ado, I would like to pass this time live from some random condo, Mr. Matthew James Murdoch. Over to you now, Mr. Matthew.
Right, thank you for giving me this time, Mr. Timothy. It's nice to see you at your house. So my name is Matthew James Murdoch, and I'm the tester for today. So if anyone can see right here for the camera, this is the Brother I stick. You can probably see that's the ultrasonic sensor right here, and the Bluetooth module should be somewhere here. So my stick right now is connected to a power bank because disclaimer from Timothy himself. we didn't really have the time to go and get lithium-ion batteries due to the movement control order. So we're sticking with power banks right now. So without dilly and dallying, let us show how me, a blind person, would normally use an app with TalkBack Assist. Okay, and the camera woman pan over to my phone. So right now, I'm going to activate TalkBack Assist on Android. For me, I have to press the two volume buttons as such, and it should be activated right now. Yep, as mentioned by the lady. So the app is located somewhere at the center. So why do I say that? It's because blind people normally have the apps placed at a very recognizable area. They rely on muscle memory. So anything important, they'll place it in an area which they can remember. So as for me, I put the app at the center, so it should be somewhere here.
Brother Eye.
Yep, that's the one.
Double tap to activate, double tap and hold to long press.
I'm gonna double tap that.
Brother Eye. Section 1, button to connect to Brother Eye. The button is at the center of this section.
So as you can see, once the app loads up, it tells me that I can connect to Brother Eye immediately by highlighting the section. So it says at the center of section 1. Where's section 1? Is it section 1?
Section 1, button to connect to Brother Eye. The button is at the center of this section.
Thank you, lady. So I'm just gonna find that.
Connect to Brother Eye.
All right.
Double
tap.
Connecting free period. Connected.
And now the lady tells me that it's connected. We can move on to me walking and trying not to fall into a pothole. Let's do that. Okay, so it's raining, but we're gonna proceed with the live demo anyway. We're gonna walk towards the stairs, because we couldn't find a pothole nearby. But the stairs will do because it kind of simulates the sudden drop in distance as you would see in a pothole. So without much further ado, let us walk. Maiden voyage. So scared. I'm so scared. Baby steps. Baby steps. Come on. Whoa, whoa. Backing up. Backing up. Backing up. Is my camera woman on the thing? Yeah, I think she is. I can feel her.
Longitude 101.65835.
So as you can see, it's reading out the location of where the pothole is. So if I were to press OK, which is I think, oh yeah, right, that one. If I double tap, it's gonna save to Firebase.
Double tap to activate. Brother Eye.
As you can see here.
Section 1, button to connect to Brother Eye.
So if you want to see the
Button is at the
location, it
center
should
of this
be on
section.
marked locations. Show me here.
Section 2,
No,
mark location.
there we go. Double tap, and you can see here. So there's a lot of replicated ones because I was testing nearby. But yeah, this is basically what you would see after the user presses OK. So that's all for the live demo. We'll move on to the sharing of the current locations. So to find your current location in case you got lost, maybe like me. So there's a button on the section 2 that was read out by the screen reader earlier. No,
Current location.
yeah, it's on the
Updating
left side of the screen.
location.
So right
Double
there.
tap to activate.
So you have to double tap.
Alert location 8A, July
There we have it.
460th 6. 7-5.
So you see, it reads out the whole details, where your location is, where your longitude, where your latitude is. So with that on hand, you can actually know where you are. And if you want to share your location to your emergency contact, it should be right
Share location
there.
button.
Double tap. And
Share.
your contact
Hello
should
there.
be popping
I
up
am
right now.
currently at 8A,
So
July
let's see
4th.
who I want to send to.
Emily Losey Way. Jun Full Moon Face. Emily Losey Way.
Okay, I'll try to
Double
send to
tap.
this one.
Jun.
I should be on WhatsApp right now.
10. Ha 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 ha. 10 colon
Oh yes,
40
it's reading out
AM.
my messages. So I'm gonna
Double
attempt to
tap and
send
hold.
this.
Send button out of list. Double tap to activate.
And right here, I'm sending my location to my emergency contact. So with that, that kind of concludes most of the functionalities of Brother Eye. I find it great. So thank you for letting me test this thing. Back to you now, Mr. Timothy.
Wow, thank you so much for your contribution, Mr. Matthew. Your assistance is very much appreciated, and I am glad to see that you enjoy the Brother Eye stick and mobile application as well. That is good news. That is high praise. So I would like to move everyone to the next section, the final section of this video, which is the academic poster summarization of my Brother Eye project. So without further ado, I'll push everyone to that page right now. So here we have a full-blown view of the academic poster for my FYP2 project. The contents of this poster is made up of a short introduction of what Brother Eye is, its aim and objectives, which I spoke about it earlier in the video, and the various problem statements that I try to solve with Brother Eye, and the methodology that I use throughout the whole developing phase of the Brother Eye project. So I use the evolutionary prototyping model, and its phases can be seen here in this diagram. I also included the tools and software that I use, also explained in the earlier part of this video. And I also included a results segment where its contents are the screenshots of the final evolution of the mobile application, and of course, the accuracy of my training model. So before I end this video, I would like to focus on the future work segment of this poster. This is because the 4 points here are the goals I would like to achieve after the FYP2 development phase. So first point being, I would like to better improve and expand on the training model used in this Brother Eye project. This is because even though with the 92.98%, I'm confident that with more road data collected, it can better differentiate the difference between a pothole and a flat road. After which I'll probably switch over to an unsupervised training model that can help make the machine more independent so that I don't have to keep collecting, labeling, and feeding the data to the machine. And once I've perfected the models, I would like to implement them on other budget costing sensors like an infrared sensor or a budget camera to produce a more affordable and reliable blind stick. And finally, using the heat map locations on Firebase, and maybe after a few months of usage, I would like to pass all these saved longitude and latitude values to the authorities like the Dewan Bandaraya Kuala Lumpur or the Majlis Perbandaran nearby to help pinpoint the areas that have large numbers of potholes so that they can go to those areas and do the necessary maintenance to the roads. So on that note, I would like to end my video presentation here. So if there's any questions, you can always email me or WhatsApp me through the phone number and email that I'll provide at the end of this video. So that's all for now for my FYP2 video presentation. Thank you so much for listening and take care.